This is Mr. Craig, and I want to make a couple of videos dealing with gases, and this is one that's really unique because it's appeared on the AP exam as recently as 2 years ago. And it's not a difficult question, but it does make you think a little bit. So let's go ahead and get into it. This question says, consider the container in the diagram below. Actually, look at the diagram to the left initially. In chamber A, 6 liters of fluorine gas at 4 atmospheres, and in chamber B, we have 1.5 liters of neon gas at 1.75 atmospheres. The question is, calculate the partial pressure of the fluorine and the neon after the valve between the two chambers is opened. Assume the final volume of the two chambers combined is 7.5 liters. Also, calculate the total pressure of the system. One thing I want you to recognize, and in this video I made the gases pretty apparent by having A with the red color, B being the clear color or white color. I actually made it a white gas. Haven't seen a white gas recently. But that's before the valve is open, so we're actually looking at a before situation. And we know what the pressure and we know what the volume of gas A is, and we also know what the volume and the pressure of gas B happens to be. However, what we don't want to do is just assume that when we open up the valve, that when the two gases mix together, we can just say, oh, well, we had a pressure here and a pressure there. We can just add those up and it'll be a brand new final pressure. The nice thing is about this problem is that gas A will actually move into chamber B, and the gas that's in chamber B will actually move into chamber A. So they're actually mixing. So what we don't want to do is assume, oh, well, we've got our two pressures, we just add them up. That's why this question's on the AP exam and why it's been asked a couple times. The reality is A and B will not mix. And looking at the two gases, they're inert to each other. Actually, it's the neon that is the inert gas. Neon's not going to react with anything, and for the fluorine, it definitely won't form any new compounds. So knowing that is that the two particles are going to come together and make a new pressure. But what I don't want you to do is just jump in and say, oh, okay, well, we just add the two pressures up and we're done. Well, we actually have a before and after situation. For gas A, we know our initial pressure, we know our initial volume. The number of moles doesn't change, the R doesn't change, and the temperature doesn't change. So, we know that we have a final set of conditions, which happens to be the final pressure, which we're looking for, and the final volume, which was given back here at 7.5 liters. So we know what the final volume is. And this is for sample A. Okay. We'll do a calculation to find out what our final pressure is here for sample A, and then we'll do the same thing for the gas B. So we know what the initial pressure is, the initial volume, and we know what the final volume is. So we're looking for P2 here. So we want to rearrange the variables. And what that means is I'm going to bring V2 to the other side, move it diagonally. So I have my equation set up as such. Now, hopefully you should recognize that that's Boyle's equation. You don't need to memorize that for the AP exam. You won't be asked that question. But we just plug in the variables. So we have our initial pressure at 4 atmospheres. And our initial volume before the valve is opened is 6 liters. And then once we open up that valve, again, the combined volume is going to be 7.5 liters total. So we'll put our final volume down there. And when we type that in, we get a pressure of 3.2 atmospheres. Now that's a lot different than the 4 atmospheres that we just were given there. Because when you look at this, the gas that's in here is going to move over. So it's actually relaxed because it has a much larger volume that it's going to occupy. And don't worry about the gas that's in B there. Because again, the gas volume is actually getting bigger. We're going to do the same thing with gas B. So P1, V1, P2, V2. We know the same setup there for gas B, that we're looking for the final pressure. So we'll rearrange the variables as such and solve for P2. And our initial pressure for this gas was 1.75 and the volume was 1.5. So we need to make sure we have that. So 1.75 is our atmospheric pressure. And our final volume, our initial volume for chamber B was 1.5 liters. But when the gas is able to, or when the valve is opened up, the gas that's in B is now able to go into A. And it has a lot more room to move around in. So we would expect that gas pressure to decrease as well. So when we do the calculation there, we get a pressure of 0.35 atmospheres, and we would expect the pressure to drop. I mean, it's going from 1.75 to 0.35 because it's going into a much larger volume. It's going from 1.5 liters to total volume of 7.5 liters. So we would expect that pressure to drop. Now, this is the pressure for, what is in B? What do we have here? B is the neon and A is the fluorine. So this is our pressure for the neon, and this is our pressure for the fluorine. So that's that, and that's that. So we have the first part of the question answered. Now the answer to the last part, it's pretty difficult. We just take the pressure of our fluorine, let's scoot this up a little bit, pressure of our fluorine, add it to the partial pressure of our neon, and that will equal the total pressure. So take our values that we just calculated, so 3.2 atmospheres, and add it to, and again, it's adding, it's an addition of gas to the 0.35 atmospheres, and our total pressure equals 3.55. Okay. Now, this is not a difficult question. However, allowing yourself or talking yourself into this being a difficult question is one of the big problems that we have. So again, always look at the whole problem before you even begin working on it. Realize that we have a gas in A, we have a gas in B. It's an initial set of conditions, and then after we open up the valve, we have a final set of conditions. So it's a before and after. And that's exactly how I need you to think of it. Before and after. That's half of the problem-solving battle here. So I hope this video's helped. Again, not a real difficult concept here, but try not to make it any more difficult than it needs to be.